Hello everyone, this is the video lecture for College Algebra, Math 1414, Section 5.2. We are finally going to be doing trigonometry, and trig is just good enough there. Let's talk about sine, cosine, and tangent. And notice that theta that I put in the front of each one of those. You put an angle inside and you go and get an answer out of it. Well, these are all ratios. These are all yielding ratios. The first one is opposite over hypotenuse. That's sine. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Maybe this looks familiar to you. There's all kind of phrases and songs that go along with it. I'm not doing that for you today. What they're really talking about is some kind of a triangle with a theta right here. And you can see opposite of that angle is this distance. Adjacent to that angle is this distance here. And then hypotenuse is always the longest one. It's always the longest one. And so these ratios are from a particular angle. Okay, so what we're going to do is look at triangles, and we're going to make the sine, cosine, and tangent for them. Most of the time without having to know the angle. So we're just doing ratios, basically. Okay, one last thing is that we have the Pythagorean Theorem. And that is going to be, and let me go ahead and give it to you, c squared is equal to a squared plus b squared. This is one way of doing it. I don't like this way at all, honestly. Let me do it the other way. We got the hypotenuse squared is equal to the adjacent squared plus the opposite squared. So that's a good version right there. Another one is r squared is equal to x squared plus y squared. And finally, 1 is equal to cosine squared theta plus sine squared theta. Okay, that one's a little different. I don't even know if we're going to be using this one today or not. I don't want to focus too much on it. But the idea, though, is that all of these right here are the same. And all of those over here, use a different color here, all of those here are the same. When I say opposite, a lot of times I mean the y value. Not every time, but most of the time. And when I say the y value, I mean sine. Not necessarily sine squared, just sine. Same thing over here on this side. When I say adjacent, most of the time I mean an x. And if I say x, most of the time I mean a cosine. Again, not every time, but that's kind of the idea. As you move on to pre-calculus, because we're assuming that you are here, you will be seeing all of this stuff a lot more. And if you take my class in particular, I'll be using x's and y's much more freely than what they would do here in college algebra. Moving on. 5, 2, 1. Let's do it. So I have this triangle. I have an angle. They don't tell me what it is. They say a C, and then they have an A, and then they have a B. And the A's and B's, they switch up to do whatever they want. They also have angles. Angle A, notice capital A is opposite of little a. Capital B would be opposite of little b. And capital C looks like that. I put a little hat on him because C and C, you can't really tell the difference unless they're right beside each other, capital and lowercase. So I do a little hat on him so you can just say, hey, he's a capital C. If I have to use it, now you know. Let's do the rest here. So I want to find out what my hypotenuse is. I want to find out what's my hypotenuse. And so I'm going to do my Pythagorean theorem. I guess you can actually use the a squared b squared business this time. I wouldn't do this very often. I use instead x's and y's or opposites, adjacents and stuff. But this will work for now. We got 36 And we got 64. Whoa. I'm almost giving it away. I got a 100. So I got c squared is equal to 100. How do I get c? I'm going to square root both sides. Now, notice that whenever you square root both sides, normally you have a plus and minus. I totally agree. But here, we're looking for the distance of this hypotenuse. Could it be a negative distance? Not really. So I'm going to just use the positive, if that's okay. So what's the square root of 100 is simply a 10. So I got a 10 there. Okay, so now that I got my full triangle set up, I can now find the sine, cosine, and tangent. So let me redraw my triangle so it's easier to look at. I had an 8, a 6, a 10, and then that's my angle theta right there. So this is, again, my opposite. This is my adjacent. And this is my hypotenuse. Do not set up a sign thinking that, oh, well, it's A over C or something. No, never. Never. Because their A's and B's and C's are going to change on you, and then they're going to use IJK or something weird, and then the whole thing blows up. Don't do it. It's opposite, adjacent, and hypotenuse. Very important there. So, again, this is opposite over hypotenuse. 6 over 10 makes 3/5. The next one is adjacent over hypotenuse. I got 8 over 10 makes 4/5. And then finally I got opposite over adjacent. And so that would be, what, 6 over 8, which is 3/4. And we're done. Cool. And there's more. There's always more. This section is very notorious for always giving you some more work. You're never done. You got to do a little bit more. I don't want to say never. So there's these other three that I failed to mention. Cosecant, secant, and cotangent. Let me go ahead and give you those formulas. This is the hypotenuse over the opposite. This is the hypotenuse over the adjacent. And this is the adjacent over the opposite. How can I remember all these? You don't. You don't. You don't have to. These are flipped. They're flipped. Notice, opposite hypotenuse, hypotenuse opposite. They're the same thing, they're flipped. I guess you could say it's like 1 over my sine, 1 over my cosine, and 1 over my tangent. Okay, awesome. What I'm going to do is simply flip them. I'm going to take these right here, and I'm going to flip them. You ready? Here's your answers. You ready? 5 over 3. 5 over 4. 4 over 3. You're done. See? Super easy. You don't want to go and try to recalculate everything. It's already done for you. If you get the top 3, just flip them to get the bottom 3. Because it's so easy, I'm not always going to do this. Now, I'm going to do it a couple more times. But on these problems coming up, there will be some problems where they say, find the sine, cosine, and tangent, and then also find the cosecant, secant, cotangent. And I'm like, I don't know. I'm not going to do those because I'm not going to do the second half because I figure you do the first half, you flip them. Very simple. Okay, just a warning, and I think I'll give you that warning as I keep going. I'll like tell you, hey, I'm going to not finish this problem. Okay, let's set this thing up. I got a 30 here. I got a 60 here. That's a 90, by the way. Anything that's got a square box is a 90. I got a 1. I got a square root 3. And then I got a 2. And they say, find the secant of 30 degrees using this triangle thing. Okay. Between you and me, are there other ways to get something like this? If you know anything about this stuff, you could try to put this in a calculator And it might work out one way or another, and that's fine. I'm not going to do that just because I don't have a calculator pulled up, and that would be annoying to pull it up right now. Kind of half joking here. It's a good thing to have a calculator on hand. Definitely a good thing. But I want to use the problems like they say. I also think that as we go forward, it's good to push ourselves and not use a calculator immediately every time. Okay? So, and sometimes the calculator might disappoint you. Who knows? So how do we do this? How do we do this? Well, first off, secant is the flip of the cosine. If I can find cosine, then I should be good to go. If you notice here, I have an adjacent to my 30. See, there's my 30, right? 30. Here's my adjacent, and then I have my hypotenuse. And that's what I need for my cosine. It's 1 over adjacent over the hypotenuse. 1 over, and then we have here adjacent, square root 3, and then I have a 2. Cool. Well, of course, we need to simplify this thing right here. 1 over that stuff. So what you're going to do is, of course, you're going to flip it. And so then what it actually ends up being is 2 over the square root of 3. Cool. I have this really big note in my notes about this. So I'm going to read it to you straight up. Here we go. When you move on to pre-calculus and calculus, we will use Webasine, which does not require simplifying. Aha! And yes, I said it. I said it. It does not require simplifying. But, I'm still reading here. Today, we must simplify. So we're going to simplify. I want to make the point, though, that you have the right answer. And this chapter 5 here in Algebra Land, you're going to do it. And then you're going to move on. You're not going to see chapter 5 very much. I think there's only 3 sections. So, cool, right? Sure, move on. But when you get to pre-calculus, you'll be doing this stuff all the time. And this is good enough. Okay? All right, now let's keep going. I have to simplify this. And what they're wanting you to do is rationalize the denominator. You can't read that, so I just said it to you. Rationalize denominator. What does that mean? It means that I want to take this square root and I want to put it up in the numerator. How do we do that? Well, the classic way is that you simply multiply by that denominator in both the top and bottom. Notice that this doesn't actually change the value at all. It's just, sorry for that little scribble over there. That's just a scribble. And that's actually a multiply. So that's not a scribble. I multiply by whatever term this is, I multiply by it in both the top and bottom. By 1. And what happens is you're not wanting to cancel or anything. Instead, notice that square root 3 and square root 3 here will combine to make a plain old 3. You see, like on the side here, square root 3 times square root 3 is the square root of 9. You just combine them on the inside there. Square root of 9 is a plain old 3. 2 halves make a whole is essentially what's going on. And that's it. You are now done. That's the answer. Moving on. So it's actually not too bad to simplify. And I hope you think that because we're going to be doing it a lot. If you don't think that, well, I'm sorry. Because it's not here forever. How about that? It's not here forever. Cosine of pi over 3 is equal to... And they give me this triangle here. I think it's the same triangle. Let me go ahead and just draw it out here. Yeah, this is the same triangle. Okay, same triangle as last time. I don't know what pi over 3 is. I see no pi over 3s here at all. I don't know what's going on. Well, we need to convert this over into degrees. Pi over 3 times, I think it's going to be 180 over pi. The pi's are going to cancel. 180 over 3 makes us 60 degrees. So we're talking here, in reality, cosine of 60 degrees is equal to what? 60 degrees is right there. That's my 60. And so cosine, if you remember, is adjacent over hypotenuse. Adjacent is going to be this 1. And hypotenuse is the 2. It's the longest one always. So I've got 1 over 2. And you're done. Can't simplify that anymore. Okay. 5217. I got sine of theta is equal to 15 over 7. They say that the cosine of theta is equal to 8 over 17. 15 over 17? Did I say 17? Anyways, 15 over 17, 8 over 17, and then go and find my tangent of theta. Okay. So notice that my sine, again, is the opposite over the hypotenuse. And my cosine is adjacent over the hypotenuse. And so it looks like my hypotenuse is the same. It's the 17. So, let's start making a triangle. I don't know what angle this is, but my hypotenuse is 17. If my hypotenuse is the 17 for both of them, then my opposite is the 15, and adjacent is the 8. So let me just get rid of those little arrows because they look a little weird. So there's my triangle. Cool. And now they're saying, okay, well, go ahead and find tangent. Well, okay, tangent is opposite over adjacent. Opposite over adjacent. 15 over 8. And, well, that's it, actually. You're done. Okay. So here's some stuff. I got this guy. I got this guy. Now I got this guy also. And now part B, I guess. They say, now find cosecant, secant, and cotangent. Oh, it's one of those. Because we're still early on, I'm going to do one like this. I'll still do it with you. All we're going to do is flip my answers. That is it. So I had sine, 17 over 15. I'm sorry, 15 over 17. Now it's 17 over 15. There you go. My cosine now is 17 over the 8 for my secant. And then my cotangent is the flip of this guy, 8 over 15. That's it. You're done. That's how easy it is. That's why I don't stress about that much. So I got sine of t is equal to 1/4. Cosine of t is equal to the square root of 15 over 4. And then they say find the tangent of t. T, theta, whatever. All the same. In fact, in my notes, I just switched to thetas as I kept going. Because it doesn't really matter. T, theta, x, maybe sometimes. It's all the same. I want to construct a triangle. And notice that we have an opposite over hypotenuse, adjacent over hypotenuse. It's pretty simple looking. T. I got a 4. Adjacent is the square root of 15. And my opposite is a 1. There's my constructed triangle. Awesome. So now I need to find my tangent, right? Tangent of t is my opposite over the adjacent, 1 over the square root of 15. Now, I have to rationalize this. This is not good enough. So what I'm going to do is multiply by the square root 15 in both the top and the bottom, so that you get 1 square root 15 in the top divided by a plain old 15 in the bottom. And there you go. Cool. And just like last time, now find the cosecant, the secant, and the cotangent. So again, all we're going to do here is flip them. That's it. That's all we're going to do. I'm going to take this guy and I'm going to flip it. So then we got 4 over 1. Makes a 4. That's easy. I'm going to flip this guy. And so then I'm going to get a little bit more room right here if that's okay. I got 4 over the square root of 15. But now, you know that you can't actually have a square root in the bottom here because they say it's not simplified. So I'm going to, I just went and did it. I'm going to multiply by square root 15 in the top and bottom. And basically, I move it up and I leave the number behind. Did you hear me say that? I said I moved the square root up, but I left the number behind. That's the quick way to do it. You just pop it. You don't have to actually multiply every time. Last one, I had square root 15 over 15, but then I'm going to flip it, right? Sorry. So it's 15 over the square root of 15, and then I have to, figure that out. Whoa, 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 whoa. Right here. Isn't that also equal to tangent? Isn't that still your answer? It's just that it's not simplified. Couldn't I just flip this one? Square root of 15 over 1? The point that I'm trying to make is that it's sometimes easier to go back to something that you already had and flip that one instead. You don't need to start with this guy and then flip it. That's already way overcomplicated. They say it's simplified. I totally disagree. But that's just between you and me. 5-2-23. It says, use the formula. Uses with an E right there. Use the formula. Sine squared theta plus cosine squared theta is equal to 1. And they say sine theta is equal to square root 6 divided by 5. And then they say find the cosine. It's a really great question. I want to just make sure you understand what this notation is. I said sine squared of theta. Sine squared of theta. What that actually is sine theta all squared. It's whatever you had, and then I square it. Same thing with the cosine. And so if I were to rewrite this here, I've got sine theta squared plus cosine theta squared is equal to 1. Now, here's my question. Why don't we just write it like that every time? I don't know. I'm not kidding you. It's just something math people made up. They said, I don't like it like this. And then they just made it like this. And, well, if you like it, cool. If you're confused, I'm sorry. This is part of life. You ever just wonder why some things in English are spelled the way they are? Or why we pronounce it a certain way in English? I mean, I'm looking at it. There's no rules in my mind. I can't spell English to save my life because there's always something else that somebody made up. At least that's what I say. My wife does not think that. She actually knows the rules to all that English stuff. Moving on. So I know the math rules, and this is what it looks like. Well, I have a sine, and I can literally just plug that in. So square root of 6 over 5, all squared. And I still don't know this one. But I'm trying to find it. It's kind of like a solve for x. If you want to just get rid of this guy and just put an x here, for one thing, I would say congratulations, that's correct. Cosine is x, but I'm not going down that road right now. And it would also look easier to solve for x if you wanted to. Regardless, I'm trying to solve for this thing. How do I do it? Well, first off, let's simplify this thing. The square distributes to both the top and the bottom, and I would get a 6 over 25. Hope you don't mind me going back to the original. I'm going to, of course, move this to the other side by subtracting it. One minus 6 over 25 is, what, 19 over 25? So what I'm looking at right now is right here and right here. And how do I solve it? I'm going to square root both sides. What that does is it makes just the cosine, which we're looking for, that's my answer, is the square root of 19 over 25, like this. Well, you distribute your square root to both of those individually. I don't know what the square root of 19 is, but that's just a 5 down there. And there we go. The end. Cool, cool. Next one, 5-2-25. Sine of 81 degrees times cosecant of 81 degrees is equal to what? This is not supposed to be a trick problem. Cosecant is 1 over sine. I had told you that a while ago. And guess what? They cancel, leaving the 1 behind. Next problem. There's nothing else to talk about there. Very, very simple. I have sine squared of pi over 4 plus cosine squared of pi over 4 is equal to what? You know what's funny about this problem here? Scroll back up, scroll back up, scroll back up. Sine squared plus cosine squared is equal to 1. Sine squared plus cosine squared is equal to 1. You're done. Doesn't matter what angle it is. I mean, that's 45 degrees is what that is. But regardless, sine squared plus cosine squared, it's 1. I even have a note in my notes saying, go back in the notes. To the previous problem, that is. I just thought that would be funny. So I got sine of 9 degrees is equal to what? And what they're wanting here is they're saying something like use cosine or something like that. Do they have words here? Cofunction? I think it's cofunction. Every sine, cosine, or tangent has a co. Or it has a co already, and you have to go backwards to get the non-co version. Sine has cosecant, by the way. That's what we're going to in this. But no, wait. No, I'm sorry. Yeah. Okay. Pause. I was thinking. Yeah. See, it says use cosine right there. Duh. This cofunction stuff, sine and cosine. I was misthinking. Hey, this is impromptu. Anyways, let me write out what sine actually is. That's how you actually spell sine. And so cosine looks like this. This is the English for sine and cosine. Every function has a co. All right, now that we talked about it, now we can actually do it. There's a formula. And it's super easy. Sine of theta is equal to cosine of 90 minus theta. So I've got my sine of 9 degrees is equal to the cosine of 90 minus 9 degrees. That's the cosine of 81 degrees. And that is literally what you type into MyMathLab. COS81. I don't know if you have to do the degree symbol or not. Enter. And you're done. Let's do another one like this. 5 to 35. Cofunction again. I'm not going to mess this one up. It says that I have a tangent of 2 pi over 5, and so this is now equal to, and then what's the cofunction for tangent? It's cotangent. Cotangent. You got tangent, and then you've got, you ready? Cotangent. See how those are the same? Every function has a co. All right, glad we talked about it. So, what's the formula for this one? I'm sure there's something that goes inside the box here. Probably have to type the whole thing. Well, here's my problem. It's in radians, and I'm getting freaked out. Well, here's the formula, by the way. Tangent is equal to cotangent of 90 minus theta. But then you can also use the Radian Mode version, which is pi over 2 minus the theta. This is the one we'll be using. And so, tangent of the 2 pi over 5 is equal to the cotangent of pi over 2 minus 2 pi over 5. Now, I have no clue what this thing is, but we can go and do that in the calculator. How do you do that in the calculator? You got 1/2 minus 2/5. Do not put the pi. Don't put the pi. Your calculator probably would freak out if you put a pi in there and it wouldn't understand. It would just give you some kind of decimal. But see, I got a nice easy fraction. And I'm like, oh wait, you're right. Ha, we have a pi. Silly me. So, tangent of 2 pi over 5 is equal to the cotangent of 1/10 pi or pi over 10 or whatever you want to put. Ta-da! All right, awesome. Just a formula, just a formula. The next couple are wanting you to use your calculator legitimately. And so I've got tangent of 56.5 degrees is equal to what? Round to, I don't know, some 3 decimals or something, 2 decimals, 4 decimals, 6 decimals, I don't know. So I put tangent in 56.5, enter, and I get, hold on, yes. Hold on, I want to find the mode. I'm giving it away, aren't I? No. Okay, give me 1 second here. My calculator is... I don't use this every day. You're going to hang on with me, right? So I'll talk about it as I'm trying to remember how to figure this thing out. There is degree mode, and then there's radian mode. And I'm wanting to convert this over from degrees to radians or radians to degrees. Okay, there we go. Found it. Finally. Okay, perfect. Enter. Yep. Okay, let me give you some answers. I got negative 0.048706, or I've got the 1.5108. How do I get two different answers from my calculator? Well, it's again radians and degrees. So this one here is actually from my degree mode. And this is from my radian mode. What are we talking about here, though? Isn't that degrees? And that's it. Very simple. This is not your answer. But my point is that if you're going to your calculator and you get a number and you type it in and it goes, no, you're wrong. And you're like, I know I'm right. I don't know what else is wrong here. Tangent 56.5, enter. It's so simple. What's wrong? It might be your mode. You need to find out how to change your mode. Like I just figured this little calculator out. To figure out how to find the degree or radian mode, Desmos Scientific Calculator has a degree radian mode button at the bottom. So it's very simple to use. Lots of different ways to do it, but you've got to get it in the right mode. Here, let's do another one. And again, I want to make sure that you're seeing the differences. So I got cosecant. While I'm looking around my calculator, I don't see a cosecant button, but I see a sine button, and it's 1 over the sine. So let me go and put that in. And I've got 1 divided by sine of 26, enter. And I got two answers, 1.31137, or I got 2.2812. And I'm wondering, well, which of these is the right answer? Again, it's between radians and degrees. I got this guy from radian mode. I got this one from degree mode. This is degrees. So this is your answer. That is not. I'm not going to do this every single time. Like, you should not be doing this every single time. Just switch it to degree mode and do it. But here on the next one, notice that I have cosine of 7 pi over 16. Now we're talking radian mode. So now you need to put it in radian mode. Well, let me go and find my answers here. So I got my cosine, 7 pi divided by 16. And I've got 0.19509. Or, let me change my mode here and see if I got another answer here. I got 0.999712. This came from radian mode. This came from degree mode. This is not my answer. This is my answer. Is there a way to just know that you're doing it right or not? Not consistently. I would say it's very difficult to know if you're right or wrong, if you're putting in the correct decimals or not, without checking the mode. You got to check the mode. Okay? 5, 2, 49. I have a triangle. It's not a very good triangle. I got 39 degrees. I got a little A, and I got a little B that says 410 centimeters. And they say find A in centimeters. Okay. I need to find A, and I'm thinking Pythagorean Theorem or something. Well, I'm missing A. I'm also missing the hypotenuse. I got very little information. What I do have is an angle. I'm going to ask you, which of the sine, cosine, or tangent uses these two values? Out of these three options, which one uses the opposite and the adjacent at the same time? It's going to be tangent. Tangent of 39 degrees is going to be my opposite over the adjacent. That is my A over the 410. So to solve for A, I simply take that 410 and move it over. Little a is equal to 410 tangent of 39 degrees. Remember to make sure you're in degree mode. See how you're doing degrees? So make sure your calculator's in degree mode. Mine's in degree mode. Cool. So then I can type that thing in exactly as you see it. Enter. And I got my answer. 332.01145. And that's in centimeters. Awesome. Let's keep going. Next one. 5, 2, 55. I've got cosine of theta is equal to 0.2664, and they want to know what is the angle in degrees. First off, make sure you're in degree mode, because we're going to be using our calculator here. Now, you probably did in degree mode from the last problem, but the point is don't change it back to radians unless you see radians. Okay. So we're in degree mode, cool, and so I type cosine of 0.2664. No. What you're wanting to do is you want to find the angle. What you have right now is the ratio. You have the answer. Now you just need the question. You need to go backwards. Like, you can't even spell that. You can't see it, so I'm just going to say it's backwards. So what do we do? How do we do that? Well, if you look on your calculator where you press the sine, cosine, and tangent buttons normally, there's another mode, like a shift or a secant or another color or something. And this time we're looking for the arc cosine. The arc cosine. Now, this is not a theta inside. This is a ratio. This is some kind of a ratio. Whatever that is. It's a number of some kind. You're looking for the arc cosine, and what you want to put in particular in there is 0.2664, and then you're going to get your answer immediately with degrees, as long as you're in degree mode. So I'm in degree mode. Cool. So I press shift and then cosine. It puts a little -1 up there. 0.2664. I hit the enter button. 74.549 degrees. Awesome. Now, I said it very quickly, but that is called arc cosine. And if you somehow type that, then I understand you. You're like, hey, how do I email you about this stuff? Type it like that. That's what I'm going to type to you. I can't do little -1s in an email. So type arc cosine. The arc means that you're finding the angle. Find the angle given that the cosine is this guy, and that's what your answer is. It's the angle. Okay, it's going backwards. And it's a very, very handy function to have. So why is there just a little -1 up there? Oh, here we go. I have a little pet peeve I got to talk about. Do you remember back a second ago that we got cosine squared? And I said, hey, that's cosine theta with a square, the whole thing squared. Yes. But now arc cosine with a -1, can I simply just put a little -1 out there? No! False! You don't do anything. It's equal to arc cosine. Now, if if you did see, I don't think you'll ever see it, who knows. This is a pet peeve, we got to talk about it. If you do see this, what it means is 1 over the cosine, which actually, if you kind of think about it, is secant. Yeah, is secant. These are not the same. These are not the same at all. So here's the thing. Why did somebody put a little 2 up there to start with? Well, you know, somebody thought it'd be funny and maybe it's easier to write. Why did someone put a -1 up there? Because they're really wanting us to be stressed. Okay, maybe it's just me. This just means inverse. It does not mean flip it upside down or something like that. It means arc. And similarly, with the sine and the cosine, by the way, don't put theta. It's not a theta in there. You're finding theta from all this. See, I was about to do it myself. I was about to do it. Don't do it. Don't do it. Okay, so sine, arc sine, tangent, arc tangent, same kind of stuff. Okay, we got our answer, right? Yeah, 74. Okay, we're good. Moving on. Last page. I got 2 more questions. Here we go. 5 to 77. You're getting your money's worth out of this one. It's a good, solid lecture. 6 degrees. They do not know what C or my hypotenuse is. They say that we have 850 feet here, and what they have here is a plane. So a plane is flying in the air. You're down here looking at the plane. You're like, oh, the plane is definitely 850 feet up high, because, I don't know, you're on the radio and they're telling you the altitude or something, and you're looking at it, and it's a 6-degree angle from the ground, from the horizontal. So how far away are you from that airplane? That's a good question. Notice that we have to use sine, cosine, or tangent. Those are the basic 3 here. So which one would I use in this particular case? I'm going to tell you it's sine, because we have opposite and we have a hypotenuse. And that's exactly what sine is equal to. And so I've got now sine of the 6 degrees is equal to my opposite over hypotenuse, 850 divided by C. To solve for C, I'm actually going to multiply it over here and then divide by the sine to the other side. So then you have a sine of 6 degrees down here. You literally type that straight into the calculator. Make sure you're in degree mode. I know you're probably still in degree mode from the last problem, but if you're kind of jumping around or you want to come back to this lecture or something, like, why is it not working? Put it in degree mode. And I got 8131.756. And I think that's in feet. Yeah, feet. There you go. Cool, cool. Last question of the lecture. 9279. I got this, it's like a power pole, you know, like power lines and all that kind of stuff. At least I think it is. Something like that. And they have an angle coming down to the ground here of theta. They say that this wire here is 85 feet long, and we know that the pole itself is 60 feet tall. So find theta. What is theta equal to? What kind of... Here's the thing. I have a telephone pole, and I know that it's 60 feet tall, and I have to run a wire down to the ground. And I know the wire's always going to be 85 feet. That's just, there's a standard 85-foot cable. I'm just making something up. I don't know. So then what kind of angle am I expecting for it to pull down on that telephone pole? And so, well, let's do the math. I have this triangle here. And there's my angle. It's a little different than normal, so be careful, okay? Out of the sine, cosine, or tangent, which one is most appealing? Which one makes the most sense? And I'm going to say it's sine, because No, I'm sorry, that was wrong. I thought that too. Look, it's the opposite. No. It's adjacent here, cosine, and then I got my hypotenuse. Well, I'm glad I fixed that before I made a real big mistake. But you can see that it really does mess with you when you got this angle in a different place. It's like I'm trying to rethink my mind here. Well, this side is adjacent, and that's my longest hypotenuse. Adjacent and hypotenuse. There we go. So if I just messed up and I knew the answer, you see my point. Okay, I would like, I want to simplify or move it over. There's nothing to do. I just need to find theta. So how do I do that? I'm going to arc cosine both sides. Arc cosine both sides. And these guys cancel out one another, leaving behind the theta is now arc cosine of 60 over 85. And it's blank degrees. Calculator. Again, I keep writing it. Degree mode. Now, we've done that a lot, but there has been a couple radian modes that we had to do. So watch out. You will have to switch. Make sure you know how to use your calculator. 45.09912. Round to whatever decimals they're looking for. And we're done. Whew. All right, guys. Thank you very much. Have a great day.